This is a typical metropolitan air terminal. Busy, bustling, working around the clock. Time has become an important factor in our economy. People prefer to fly, and economic surveys forecast a steady rise in passenger volume. Time in air transportation means speed, and speed means jets. Jet air travel will have immense passenger appeal. Airlines will very soon require a jet airliner that is profitable to fly on medium and short-range flights. It must be rugged, dependable, versatile, fast. To build it, the manufacturer must have advanced design and engineering concepts, experienced craftsmen, and a proven manufacturing might. Convair is such an organization. For economic stability, Convair can rely on the productive vigor and financial strength of its parent organization, General Dynamics Corporation. General Dynamics' 7 divisions are Electric Boat, builder of the Nautilus, Seawolf, and Skate, first atomic submarines. General Atomic, nuclear energy research and production. Canadair, Canadian military and commercial aircraft, and atomic reactor design and construction. Liquid Carbonic, this country's largest producer of carbon dioxide, of great importance in the expanding missile field. Electrodynamics, motors and generators of advanced design for specialized use. Stromberg Carlson, communications and electronics equipment for commercial and military use. And Convair, largest of the General Dynamics divisions. Convair was merged with the corporation in 1954. The fusing of these diverse concerns into the industrial network that has become General Dynamics Corporation is the accomplishment of the late John J. Hopkins, founder and chairman of the board. Mr. Hopkins was among the first to envision the great potentials of the atomic era, and he put this vision to work through General Dynamics. The energy and courage of the building days is reinforced and carried on now by President Frank Pace, former Secretary of the Army and Federal Budget Director. With Mr. Pace is Executive Vice President Earl Johnson, whose extensive experience in aviation and business is typical of the sound executive background at General Dynamics. The goals set by Mr. Pace for the corporation, now employing 90,000 people, include even greater growth and stability. A basic aim of the corporation is to balance its earnings equally between military and commercial activity. Net sales for the year 1957 were $1,500 million, an increase of nearly 50% over 1956. Unfilled orders and contracts under negotiation for the year 1957 exceeded $2 billion. Recently retired Convair president Joseph T. McNarney brought to the aircraft industry the same quality of vision and administrative integrity that has made General Dynamics an industrial empire. Before his retirement from the Air Force, General McNarney succeeded General Dwight Eisenhower as Supreme Allied Commander in Europe and headed the Air Materiel Command, controlling the major portion of the buying power of the United States Air Force. Former Executive Vice President Jack Nash succeeded General McNarney as Convair president. He gives to Convair his unique and valuable combination of manufacturing, sales, and financial experience. With this quality of leadership, Convair has achieved the most diversified aircraft product line in the industry. From its own 5 subdivisions, located in California and Texas, have come a roster of aviation milestones, from huge multi-engine to revolutionary single-engine aircraft. The famous PBY Catalina. Pilots called it indestructible for the roughest patrol and rescue work. B-54 Liberator. 18,000 of these saw World War II duty around the world. R-3Y Tradewinds, first 1st, 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 first vertical takeoff aircraft ever flown. Its unique flight abilities brought about flight without runways, a long dreamed of advance. B-56, the world's first true intercontinental bomber. For 10 critical years, this nation's deterrent to global war. Convair's present product line consists of the Navy's Terrier, first operational surface-to-air missile, and its successor, the Tartar. The B-58 Hustler. This sleek four-engine Air Force nuclear weapon has already compiled more supersonic flight hours in its early test stage than all other American supersonic aircraft combined. The F-102 Dagger, first of the deadly Delta Series supersonic all-weather interceptors, now defending the North American continent. The F-106 Dart, details secret, but it can be described as America's most advanced all-weather interceptor. And the Atlas Intercontinental Ballistic Missile, destined to be the first operational Air Force ICBM. Dagger, Dart, Hustler, Atlas, America's 4 most advanced defense weapons, and military projects for the future yet to be revealed. Convair management has applied the experience gained in these diversified programs to advantage in its commercial efforts, as is apparent in the acclaim afforded the Convair liners, famous for their unequaled passenger safety record and sound structure. The 240 is the pioneer of the Convair liner series. Its unique economy engineering features are maintained in the larger 340. The 440 Metropolitan incorporates the best features of both into the quietest, most efficient plane of its kind in service. Convair has built more post-war transport aircraft than any other manufacturer. The Convair liners are designed specifically for medium and short-range flight, allowing operators to fly them around the clock at minimum passenger mile cost. More than 1,000 commercial and military Convair liners have been built and are in service with more airlines than any other post-war aircraft model. What gives an airplane the ability of flight? How does it get its shape, its size, its motion? From 16 million square feet of design and production floor space in Convair's 5 divisions comes the answer. Research and develop. Design and test. Then tool and manufacture. And do it better, faster, and more economically than ever before. Convair's research and development efforts have accounted for hundreds of aviation firsts. As an example, the Delta Wing. Other designers said it was impractical, yet first tested on Convair XF-92 in 1948, the Delta Wing made possible the great achievements of altitude and speed of the F-102, F-106, and the B-58. Some of the most penetrating minds of our time are retained by Convair to work with management and research groups. Famous names in theoretical, nuclear and solid-state physics, aeronautics, astronomy, and many other fields of research. By maintaining a ratio of 1 engineer, scientist, or technician to every 4 production workers, Convair is able to constantly push back the barriers to new knowledge, new principles, new methods, 10, 15, and 20 years ahead of current designs. In 1957, Convair spent $4 million for engineering research in areas so advanced that airspeeds of more than 10,000 miles per hour are being considered. Millions of dollars have been spent for testing sites and laboratories. Some Convair facilities are the only ones of their kind in existence. This electronic cooling test stand can produce temperature and pressure effects of flight up to 90,000 feet and 3,500 miles per hour, flight conditions that men in machines are only now reaching. The new Convair high-speed wind tunnel will have a simulated airspeed capacity of 5 times the speed of sound. From this constant search into tomorrow and the proven skills of today comes the Convair 880 Jetliner, which will make possible profitable intermediate and short-range operations previously denied to jets. $50 million has already been spent on the 880 program, $10 million on engineering alone. By the end of 1958, another $50 million will have been spent. This is the heritage of the 880. Wingspan, 120 feet. Length, 130 feet, about the same size as existing four-engine aircraft. Speed, 615 miles an hour, the fastest jetliner in the world. Los Angeles to Chicago, 3 hours, 12 minutes. New York to Chicago, 1 hour, 31 minutes. Miami to New York, 2 hours, 9 minutes. It will operate from the existing facilities of over 350 cities serving the air routes of the world. Its versatility makes it capable of transcontinental use and even wide application to secondary intercontinental routes. For example, London to Rome, 1 hour, 48 minutes. Paris to Cairo, 3 hours, 35 minutes. Cairo to Tehran, 2 hours, 22 minutes. It is the first American-built jet transport designed specifically for intermediate range. A medium-range aircraft is subjected to more severe structural fatigue than a long-range airliner. Convair is 2 years ahead in this field of fatigue and vibration testing. 1/20th scale models of the 880 in perfect detail are built with watchmaker precision for wind tunnel testing. The models demonstrate the aerodynamic characteristics of the real airplane exactly before its first flight. The most advanced tooling and machine methods and equipment in existence are used to make 880 construction as economical and efficient as possible. Vast areas filled with machines capable of thousands of intricate metalworking functions. Machines of every type and size. Small ones, large ones, machines that require close attention, machines that are completely automatic, machines that without aid duplicate elaborate metal patterns, following a master form by mechanical touch or guided by a blueprint reading electronic eye, machines that drill, trim, cut, form, join, bend, and punch. Many of them Convair designed and patented, like this high-draw press. Cost, $750,000. Weight, 1,500,000 pounds. Its 7,000-ton pressures create in a single movement large components that formerly required time-consuming pre-assembly. One of the largest spar mills in the United States will be used for the 880's main wing spar. The world's largest radial draw former uses Herculean pressure of 75 tons to form the belt frames that will encircle the 880's fuselage. This one installation with related fixtures was made at a cost of $800,000. Metal to be formed is heat-treated in this mammoth oven and then within a few seconds dropped into the tempering tank. This process gives 880 parts more strength with less weight. Hidden inside the 880's huge wings in every key fuel tank area where metal meets metal is a built-in miracle, a miracle called Scotch Weld. Scotch Weld is a revolutionary new bonding process developed by Convair and the Minnesota Mining and Manufacturing Company. Used with Convair-developed riveting, Scotch-welded wing elements have great fuel-tight integrity and added structural strength that other manufacturers have strived for years to build into their airplanes without success. Scotch Weld will give the 880 a leak-proof fuel tank system that will pay high dividends in trouble-free service and greatly extended aircraft life. Scotch Weld is the proven answer, and Convair has it now, at least 2 years ahead of the aircraft industry. The giant Scotch Weld curing oven large enough to hold both 880 wings, is heated to carefully controlled temperatures to complete the bonding process. Scotch welded integral tanks in the hundreds of F-102 daggers in over 4 years of rugged military use have not developed a single case of fuel leakage. The F-106 is proving the case of Scotch Weld even further. The 880 will be the only jet airliner with a great advantage of Scotch Weld bonding, which makes it possible to use the whole wing as one huge fuel tank. An airplane can only earn while it's in the sky. Research, experimentation, and far-sighted design have cut turnaround to a minimum and given the 880 an earning potential 3 times as high as comparable 4-engine propeller planes. For instance, the engine pods are clamshell designed for quick access and removal, a package feature that greatly reduces maintenance and repair time. The CJ805 General Electric engines that will power the 880 have proven their ability in the B-58 Hustler. These lightweight units are the most advanced engines made, with the highest thrust-to-weight ratio yet achieved. General Electric has built more jet engines than any other manufacturer. The engine is lowered on a specially designed cart to be maneuvered easily to the maintenance area. Total engine replacement time, 30 minutes. Far less than piston engine requirements. This package concept has been carried out all through 880 design. For example, left and right main landing gear units are interchangeable, cutting in half the operator's parts in stock cost. Convair's complete 880 customer support program includes such streamlined service as an integrated data processing system to control and simplify the handling, stocking, and ordering of spare parts and assemblies. Passengers on their first 880 flight will take for granted these standards of engineering excellence. Their first impressions will include the colorful interior decor by Harley Earl and Dorothy Draper, impressions of spacious and luxurious comfort. The 880 is the only American-made jetliner initially designed to offer 4 abreast seating, and passengers will enjoy the quiet and absence of vibration that is typical of jet flight. The cabin will be pressurized at sea level up to 20,000 feet and pressure equivalent to 6,000 feet at cruising altitude of 35,000 feet, well within the comfort range. A window for each seat gives superb visibility. Compact galleys provide delicious buffet meals, which can be enjoyed on folding desks. Ample storage room puts personal property at the passenger's disposal in flight. Luxurious appointments are everywhere in the 880 interior. Here is the 880's comfortable and friendly lounge area. Airlines can offer passengers a choice of an 88-passenger deluxe or a 111-passenger coach version, and the necessary seating change can be made in just 4 hours by a few men. This time-saving feature is typical of the attention given by Convair to details that will reduce the 880's out-of-service time and eliminate maintenance. The first 880 will roll out of the plant in November 1958. Chief Pilot Germerod makes his first test flight in the first part of 1959, and airline deliveries to TWA, Delta, Real Aerovias of Brazil, Transcontinental of Argentina, and Capital begin less than a year later. Many other domestic and foreign airlines are studying application of the 880 to their route systems. Regular commercial flights start in May 1960. The 880 is a direct result of the forward-looking research, development, and manufacturing skill that have made Convair a leader in the aircraft industry. The broad horizons of Convair engineering and manufacturing research and development have made possible great advances in meeting the rising standards and requirements of modern aviation. Because of the constant penetration into the problems of motion in time and space for the needs of tomorrow, Convair and General Dynamics have found superlative answers for the needs of today. One of these is the 880 Jetliner.